Hi guys. Okay, so I'm going to go over the Chapter 2 quiz review in a video, even though this was a homework assignment to get you guys ready for the quiz. I'm going to post this. Hopefully, you're watching this Monday morning before you take the actual quiz, okay? Because this is the review, and we'll kind of give you a heads up on what's going on. Okay, so the first question says a group of 78 third grade students in a Midwestern elementary school took a self concept test. Um, Higher scores indicate more positive self concepts, etc. So as you come down here, you've got descriptive statistics. N stands for how many students, so that's 78. This mean is the average. You don't know what the SE of the mean is, so you can ignore that. This is standard deviation. And then your 5-number summary: minimum, quartile 1, median, quartile 3, max. Okay, so real simple. Question A says 33 students had a self concept score higher than a 62. One student had a score of 62. Calculate and interpret the student's percentile and z-score. So percentile first. So percentile is going to be the number of students, right, that scored 62 or less, divided by total number of students. Okay, so this is really simple. It tells you that 33 students had a self-concept score higher than 62. Okay, well, if you take 78 students, and let me try to fix this if I can make it darker. If I take 78 students and I subtract 33, those 33 had higher scores. There's 45 students that were at a 62 or lower. Okay, so your percentile is going to be 45 divided by 78. 45 divided by 78, you get 0.58 approximately. Okay, and so you would say, cognitive the students percentile score is 58th percentile. Okay, so it says calculate and interpret. So what does this mean? So you get a point for writing 58th percentile. So you would say 58% of students scored 62 or less. Okay, and so you do have to interpret. So you get 2 points for calculating the correct percentile, 2 points as always for interpretation. Okay, so then we've got a z-score that we're supposed to find. So far, you guys, just as kind of a review here, notation. We know the word mean. Okay, x bar, that's called the sample mean. Sometimes I'll use the symbol mu. That's the population mean. Okay, but both of those symbols would be used as the mean. In this case, we don't even need to use symbols. We can just calculate it by words. Okay, also the standard deviation. Sometimes it's written as S sub x. That's the sample standard deviation. Sometimes it's written as that weird Greek symbol, lowercase s. That's population standard deviation. Okay, but in general, the z-score is just your value minus the mean divided by standard deviation. Okay, so you don't have to worry about notation at this point. You would just say, look, z is equal to the value of the score, which is 62, subtracting the mean, which up here says 56.85, and dividing by the standard deviation, which is right here, 12.35. Okay, and I mentioned this in class, but some of you, are not there, obviously. So be careful when you do this. So if you type in 62 minus 56.85 divided by 12.35, PEMDAS is going to fail here, right? Because you're going to do division first. So don't do that. So when you have your phone out, if that's what you're using, or your calculator at home, just hit the top and then enter, and then divide by 12.35 to get your correct answer of 0.42. I'm just rounding to 2 decimal places. Okay, so the score, interpretation, the score of 62 is 0.42 standard deviations It's above the mean because it's positive. If it was negative, it would be below. So the score of 62 is 0.4 standard deviations above the mean. Okay. Again, 2 points here, 2 points here. So front page of your quiz would be 2, 4, 6, 8 points. Okay. All right. So let's go on to the last question here. This goes pretty quickly. This is what's called a cumulative relative frequency graph. In the notes, we've gone over this. It's pretty straightforward. It talks about the length of songs in minutes. And then over here is your cumulative relative frequency, which goes from 0 to 1. And this gives you, again, your percent. Okay, so let's find the median and IQR. So what we're going to do is we're going to say, well, the median is the 50th percentile, which would be right here. And so you do a straight line over and then a straight line down, and you estimate. It looks like, 3.8 minutes. So just say 3.8 minutes. Obviously, your estimate needs to be pretty close. If you write down over 4, that would be incorrect. If you wrote down 3, that would be incorrect. This is clearly over 3.5. So anywhere between 3.5 and 4, I would accept. Okay. In order to find IQR, I need to know quartile 1. Well, quartile 1 is 0.25. So again, if I come over and down here, that looks like about 3.2 minutes. And I need quartile 3, which would be up here at 0.75. So if I come over and down here, I'm at like 4.8. Again, all estimates. So I'll be, lenient on what you say. And so then you can say, look, the IQR is simply quartile 3 minus quartile 1, which would be 4.8 minus 3.2, which would be 1.6 minutes. Okay, so find it, the median and interquartile range. You did both of those, so 2 points, 2 points. Draw lines on the graph to show how you arrived at your answer. 2 points. Okay. Obviously, on a quiz, you're not really going to be able to draw on there. So if it's obviously going to be given online, don't worry about those 2 points. Okay, then the last thing down here, according to the data, the mean song length was 4.23. So I'm going to write mean equals 4.23 minutes. And we have the standard deviation is 1.38 minutes. So a music lover who wants to create a mix of songs wants to have 5 seconds of silence. So he needs to add 5 seconds to the length of each song. So this question asks you to find. He also wants to express the time in seconds rather than minutes. So what happens to the mean and the standard deviation if you add a number? So if you add a number to data, the mean gets that number added to it. Standard deviation, nothing. Okay? And so if you add 5, it's not going to affect the spread, right? Again, go back to those notes, right? If you have a bunch of data and you just add 5 to all those data points, this whole thing just shifts over 5. The spread does not change. So you would say the new mean would be equal to 4.23 plus 5, which would be 9.23 minutes. And the standard deviation is still 1.38 minutes. So this is what happens when you add. Now, there's another part to this, though. Okay, so this is not your answer. You now want to express the time in seconds, okay, rather than minutes. Well, just think about it, right? Like in your brain, you guys, if you have 2 minutes, we all know that that's equal to 60 seconds, right, times 2, right? And so what you're doing here, you would say that that's equal to 120 seconds. And the way that you're getting there is you're multiplying by 60, right? Sorry, let me scroll down here. So if you guys know 2 minutes is equal to 120 seconds. So how did I get there? Well, I multiplied by 60. So this next question, what happens when you multiply by 60? Well, the mean stays the same. Does it? No. Mean gets multiplied by 60. Sorry. So if you go up to your data and you multiply every value, right, by 60, all of your data is going to be way bigger. So your average is going to be way bigger. And so you would say your new mean is going to be equal to 9.23 times 60. And you get 553.8 seconds. And what happens to your new standard deviation? Well, when you multiply data, it's definitely going to change. It's all going to spread out. It's not like you're doing the same thing to everything, right? You're taking every number and adding 5. That just shifts it over. But when you multiply 10 by 60, you get 600. When you multiply 15 by 60, you get a much bigger number. So your spread gets changed. And again, that goes back to the notes on that section. Multiplying will change both the mean and the standard deviation. So you'd say 1.38 times 60, and you get 82.8 seconds. Okay, so this last question maybe is going to be the harder one for you, so you just want to review it. But in general, it's just going to ask you, right, what happens when you add something and what happens when you multiply? When you add a number, and go back to your notes, your measures of center all will get that added to it. The quartiles go up, the max goes up, the min goes up. But the spread, standard deviation, nothing happens to it when you add. But when you multiply, everything changes, right? Your mean will change and your standard deviation will change. Okay, so I hope that helps. You guys definitely watch that and maybe watch it again before you start your quiz.